Hello everyone. Today we have pre-calc lesson 22. We're going to talk about the absolute value and the reciprocal function. Now the absolute value we've seen before, but its actual definition is the distance from zero. Okay, so if we said the absolute value of -2, right, we know that this is 2 from 0. Okay. Now, if we looked at the absolute value of x less than 0, this has no solution because we know that the absolute value takes away a negative. And the absolute value of x greater than 0 has all the solutions, which we would say is all real numbers as our solution. Okay, and say we had something like the absolute value of x is less than a number versus the absolute value of x is greater than a number. There are two cases for each. One case is we have x minus a is less than a number, and the other is x minus a is greater than a number. Okay, so I'm going to show you what each of these look on a number line. We're graphing on a number line. Okay, so here's a couple examples. I'm just going to say examples. We're going to graph each on a number line. Okay, so the first, we have the absolute value of x minus 2 is less than 0. Okay, so we add 2 over, and we get the absolute value of x is less than 2. Which we know we can graph this, right? The absolute value of x less than 2. Okay, I'm going to have 0, 1, 2, -1, -2. Now, this is where we say that there are two solutions, two cases. Okay, if we have less than, then we have a conjunction. Conjunction is for less than, meaning that this is the same thing as saying that x is less than 2 and greater than -2, which looks like this. No shading on the line. This is what I want to see. Okay, now we know this to be true because what if I plugged in a number outside of this? What if I plugged in the absolute value of -5? Is that less than 2? No. It doesn't work. Okay, so we have to have this parameter here. This does have to be part of your answer, and then we graph it. Okay, let's do another example. If we had the absolute value of x minus 5 is less than 2. Okay. Now, this is again less than. So we're going to say -2 is less than x minus 5 is less than 2. It's a conjunction. Okay. Now I'm going to add 5 everywhere. And I get 3 is less than x is less than 7, which to graph on a number line. Right, I have 1, 2, 3, 4, 5, 6, 7. Less than 7, greater than 3. Now, notice what I'm doing with my circles, right? We remember, if it's strictly less than or strictly greater than, we have an open circle. Less than or equal to is a closed circle. Okay, let's do one more example like this. The absolute value of x plus 2 is greater than or equal to 3. Now this is a greater than, which is a disjunction. Okay, so then what we have is, let's rewrite this as x minus -2 is greater than or equal to 3. And this is really important because I'm going to look at the set of all real numbers that are distance equal to or greater than 3 units away from -2. Okay, so if I was to go at -2, right, I'm looking at everything that is 3 units away from -2, okay, which would be the same if I said -3 is less than or equal to, sorry, backwards, x is less than or equal to -3 minus 2, there's my -2, right, or x is greater than or equal to 3 minus 2, again, there's my -2, which I know each of these is 3 units away, so 1, 2, 3, 1, 2, 3. This gives me 1, right? This shows me that x is less than or equal to -5, or x is greater than or equal to 1. Less than or equal to -5 looks like this. Greater than or equal to 1 looks like this. Okay, with disjunctions, you can either look at it as, right, we could look at it this way and say we are going 3 units away from -2, okay? Or we could say x plus 2 is less than or equal to -3, or x plus 2 is greater than or equal to 3, and solve both of those for x. Okay, this is one way you can look at it, this is another. Either way is fine, okay? Now, let's do a different type of example. Okay, these are all number lines, but let's sketch the graph of y equals the absolute value of x. So this is no longer on a number line because we don't have an inequality. Okay, here we are working on an actual number line. So, sun's in the way. All right, so what I'm going to do is create my XY chart so I can graph it. I'm going to plug in 0, 1, 2, -1, -2. If I plug in 0, the absolute value of 0 is 0. If I plug in 1, the absolute value is 1. 2, the absolute value is 2. -1, the absolute value is +1. And -2, the absolute value is +2. Leaving me with a V. Now, if I wanted to compare that to the graph of y equals x, I know that y equals x goes straight up through here, okay? The difference is that instead of this portion down here, it points up because the absolute value makes everything positive. Okay? All right. Let's move on to our next portion, which is reciprocal functions. Now, reciprocal functions have what is called a vertical asymptote. Oops. Okay, a vertical asymptote is a place the graph approaches but never touches or never crosses. Okay? And in a reciprocal function, it's wherever the original graph intersects the x-axis, which I'll show you an example. Okay, and we know that our reciprocal functions, they have 2 branches. Okay, 2 pieces. Okay, so let's look at y equals x. Okay, now y equals x, we should know what this looks like. Okay, I'm just going to sketch it for you. This is y equals x. Now, if we notice, it intersects the x-axis at 0, 0. So, in my reciprocal function, y equals 1 over x, I have an asymptote, which is denoted by this dotted line, okay, on where we have x equals 0, right? Because that's where we intersect the x-axis. Now, I create two branches that are going to look like this and like this. Now, I just happen to know that's what that graph looks like, but how you would do this is you would get XY charts. Now, for here, right, XY chart, if we had 2, 1, 1/2, 0, if those are the values I plugged in, then I know for y I get the same values because y equals x. Now, my reciprocal function is just that. It's the reciprocal. So if I plug in the same x values, 2, 1, 1/2, 0, for y, I get the reciprocal. So the reciprocal of 2 is 1/2. The reciprocal of 1 is 1. The reciprocal of 1/2 is 2. And 0, we say it is undefined. And it's undefined because that's where my asymptote is. Okay? My asymptote is at 0, therefore I can't have a value here. And we know that's true because we cannot have dividing by 0. That's not a thing. Okay? So let's do an example. You're about on example 5.
I need David Jerkowitz to the front desk, please. David Jerkowitz to the front desk.
Sorry about the intercom. Sketch the graph of y equals 1 over x squared. Okay, so we can see it's the reciprocal of y equals x squared, okay, which we want to graph first. Now, we should know what it looks like. It's a parabola. Okay, now, but I'm going to get some specific points. X, y, 0, 1, 2, -1, -2. If I plug in 0, I get 0. If I plug in 1, I get 1. 1 squared is 1, so 1, 1. 2, I get 4. 2, 2, 2, 2. That's going to be 4. Right? And the same is true of -1, 1, and -2, 4. Okay. Now my reciprocal, if y is 1 over x squared, okay, now I know that, again, I'm going to have an asymptote right here along the y-axis because that's where my original function touched the x-axis. And I create my xy charts. I'm going to plug in the same points. Now again, at 0, we are undefined. We can't be at 0. Okay. Now, at 1, the reciprocal of 1 is 1. Okay. Now if I plug in 2, I get the reciprocal, which is 1/4. Let me graph 1, 1. And then 2, I get a 4th down there. Okay. I think it looks like I might need to do another positive number 3. I'll get 1/9, so we can kind of see what's happening. Looking down there. What if I plugged in like 1/2? That would give me 4. So half of my graph looks like that. Very important it doesn't cross the x-axis. And we know that's true because this cannot be negative, so we can't have negative values down here. Let's look at what happens when we have a negative. So if I plug in -1, it gives me +1. -2 gives me +1/4. And we know that there are two branches that are going to act the same. That is my reciprocal function. Okay? As always, if you have any questions, bring them to class tomorrow. But that is all for lesson 22.